Welcome dear Mathletes to the next edition of Quadratic Equations. In this particular video, we'll be taking up numericals based on quadratic equations, framing the correct quadratic equation, and of course solving for x. Basically, it is like a roller coaster ride. It starts with excitement and ends with a scream for x. To begin with, let's take a very simple question. The sum of two numbers is 15. If the sum of the reciprocals is 3 by 10, find the numbers. So we need to understand the meaning of reciprocals, and it's given here that the sum of the two numbers is 15. So if we take the first number as x, the second number obviously will be 15 minus x. Now the reciprocals of these two numbers, for x it will be 1 upon x, and the reciprocal of 15 minus x will be 1 upon 15 minus x. So if we add these two numbers, according to the question, this is equal to 3 by 10. So now this is of course the equation that has been framed with the help of this particular data available to us. Now we need to convert this into the quadratic format. And for that we take the LCM. So this becomes 15 minus x plus x divided by 15x minus x squared is equal to 3 by 10. So this x and x will get cancelled. 15 is divisible by 3. Now because 15 is left alone, we can divide it by 3 and we'll get here 5. So this becomes 15x minus x squared is equal to 50, and which can be rewritten as x squared minus 15x plus 50 is equal to 0. Now this is a very simple quadratic equation, and this term obeys. So we can either do it by factorization or middle term splitting as we say, or you can use the quadratic formula. I'm taking the help of factorization. So this is 50 over here. So we can easily break it up as minus 10x minus 5x plus 50 is equal to 0. So if we solve this, x squared minus 10x minus 5x plus 50 is equal to 0. From the first two terms, we can take out x common. We are left with x minus 10. From the second two terms, we can take out minus 5 common. So we are left with x minus 10 is equal to 0. Again, x minus 10 is the common factor. So we are left with x minus 5 is equal to 0. Now, equating each of these linear factors to 0, we get x is equal to 10 or we get x is equal to 5. Now, both are possibilities. If we take the first number x as 10, the second number will be 15 minus 10, that is 5. And if we take x as 5, the second number 15 minus 5 is equal to 10. So, these are the solutions for this particular equation. Moving on, the difference of the squares of two numbers is 45. The square of the smaller number is 4 times the larger number. Determine the numbers. The difference of the squares of two numbers is 45. And then the second statement that is very important, the square of the smaller number is 4 times the larger number. Now here we need to understand, supposing we take the larger number as x, then the square of the smaller number is 4 times the larger number. That means it is only 4x, not the square of the larger number. So this has to be understood carefully. Then the question says the difference of the squares of two numbers is 45. So obviously the square of the larger number will be x squared, and we are given that the square of the smaller number is 4x. So x squared minus 4x is equal to 45. So this can be rewritten as x squared minus 4x minus 45 is equal to 0. So this becomes x squared minus 9x, and 9 into 5 is 45. So we can put here plus 5x minus 45 is equal to 0. 9 and 5 are the optimum these factors for this 45 here. So again, from the first two terms, we can take out x common. We are left with x minus 9. From the second last two terms, we can take out plus 5 common. We are left with x minus 9 is equal to 0. So again, x minus 9 is common and x plus 5 is left. So equating each one of them to 0, we get x is equal to 9 or x is equal to minus 5. Now let's analyze as to which is a probable answer over here, because both cannot be a possibility. Why? Now x is equal to 9. If I take x is equal to 9, the square of the smaller number, which is defined by 4x, will become 9 into 4. That is equal to 36. This is the smaller number. So the smaller actual number, smaller number will be equal to root over 36, that is equal to plus minus 6. So the solution can be either 9 plus 6 or it can be 9 and minus 6. Because if we square negative 6 also, it will give us 36, and positive 6 also, it will give us 36. So 81 minus 36 is obviously 45, which justifies the statement over here. But if we take negative 5, in that case what happens is the square of the smaller number becomes 9 into 5, that is, sorry, 4 into 5, that is equal to negative 20. So here, this negative 20 cannot be taken as a square of any number, hence it has to be rejected. So this negative 5 is rejected over here. Next question is, the sum of the squares of two consecutive odd positive integers is 394. Find them. Sum of the squares of two consecutive odd positive integers. So let's take the odd positive integers as x and x plus 2. The difference between any of two of them will definitely be 2. So the question says the squares of them, that means x squared plus x plus 2 the whole square is equal to 394. So this can be rewritten as x squared plus, expanding this using a plus b whole square, this becomes 4x plus 4 is equal to 394. So this becomes 2x squared plus 4x minus 390 is equal to 0. Now 2 is the common factor, we can easily eliminate that. So x squared plus 2x minus 195 is equal to 0. So this becomes now minus 195. We can either solve it with the help of quadratic formula, or we can take the factors as 195. So possible factors, if we choose 1 and 195 is not going to help us. 5 and the remainder that we get, that is 5 3 is 15, and this is 4. This is not going to help us. So if we choose 15 and this will give us 15 ones 15, and this will be 15 3s 45. So 15 and 13 is definitely going to help us. So we can write this as x squared plus 15x minus 13x minus 195 is equal to 0. So this becomes x plus 15 minus 13 x plus 15 is equal to 0. So one factor is x plus 15 and the other factor is x minus 13 is equal to 0. Equating each one of them to 0, we get x as minus 15 or x as 13. Now again here, both the solutions are not possible because the question says positive integers. That means we have to take the value of x as 13 only. So obviously the next number will be 13 plus 2, that is 15. So this is the solution. Now supposing positive is not mentioned over here, only odd integers is mentioned. In that case, if the first number is negative 15, the next number will be minus 15 plus 2, that is negative 13. But in this question, we are not going to take the solution because it's mentioned here odd positive integers. Next question is, the difference of two natural numbers is 3 and the difference of the reciprocals is 3 by 28. Find the numbers. Now here again it's natural numbers, so we need to understand, get back to the definition of natural numbers also. If the first natural number is x, the second one obviously will be x minus 3. So then the question says the difference of the reciprocals. Again, let us take the reciprocals 1 by x and 1 by x minus 3. Now here one important thing needs to be understood. This is the greater number, this is the smaller number. X is obviously greater than x minus 3. So if we take the reciprocal of 1 by x, this will be lesser than this reciprocal 1 by x minus 3. So if we are writing it this way, 1 by x minus 1 by x minus 3, then in that case, this difference must be taken as a negative value because we are subtracting a greater from a smaller. So this we have to put the negative sign preceding 3 by 28. Otherwise, we can simply write it as 1 by x minus 3 minus 1 by x is equal to 3 by 28. In fact, both of them mean the same thing. If you shift the sides, you will get the same equation over here. So now this has to be solved, first put in the format of the quadratic equation by taking the LCM. So this becomes x minus x plus 3 divided by x squared minus 3x is equal to 3 by 28. So this gets cancelled. So we are left with, and 3 is divisible by 3. So we are left with x squared minus 3x is equal to 28. So this becomes x squared minus 3x minus 28 is equal to 0. Now this can be easily solved. This is 28. So factors of 28 we can take as 7 and 4. So this becomes x squared minus 7x plus 4x minus 28 is equal to 0. So taking out x common from the first two terms, we are left with x minus 7. 4 common from the next two terms, we are left with x minus 7. So this becomes x minus 7 into x plus 4 is equal to 0. So one solution is 4 and negative 4 and one solution is 7. Again, this negative 4 cannot be taken as the answer because it is natural number. So we have to take only the answer as 7, and obviously the next number will be 7 minus 4, that is 7 minus 3, that is equal to 4. So this is the solution for this question. Moving on, we have the next question, a very interesting question. A train travels a distance of 300 km at a constant speed. If the speed of the train is increased by 5 km per hour, the journey would have taken 2 hours less. Find the original speed of the train. So the train is traveling from point A, from one station A to another station B, and it is this distance is 300 km. Now this word technically is very important, constant speed. That means whatever happens, the speed of the train is constant throughout the journey of this 300 km. Let us take the speed as x kilometer per hour as it is not given. Then the question says if the speed of the train is increased by 5 km per hour. So if the speed is increased by 5 km per hour, then the time taken for the journey will be 2 hours less. So let us frame the equation. If we have 300, it's traveling at x kilometer per hour, and this is kilometers, then the time is t hours. Then the time taken is t hours. And if it is moving at 300 kilometer, it is traveling at x plus 5 kilometers per hour, then the time is t minus 2 hours. So now we have to relate these two equations that we get over here. So here it is t minus 2. So we can easily substitute over here. We'll get here 300 by x plus 5 hours is equal to 300 by x minus 2. Now this can be rewritten as 300 by x minus 300 by x plus 5 is equal to 2. Now, before we simplify this, 300 being a big number, we can easily take it out as a common factor and simplify this as 1 by x plus 5 is equal to 2. So this becomes, taking the LCM over here, x plus 5 minus x by x squared plus 5x is equal to 2 by 300, shifting 300 there. This x and this x gets cancelled. 2 and this becomes 150. So we are left with x squared plus 5x is equal to 150 into 5, that is 750. So we are getting this equation x squared plus 5x is equal to 750. We can easily rewrite this as x squared plus 5x minus 750 is equal to 0. Now 750 being a big number, we can take the help of the quadratic formula. So this can be written as minus b, that is minus 5, plus minus b squared, that is 25, minus 4 into a, that is 1, and minus 750, that is c, by 2. So this becomes negative 5 plus minus, this is 25, and this becomes plus 3000. 750 into 4 is 3000 by 2. So this is minus 5 plus minus 3025 under root by 2. Now this is a perfect square, but let us check it out as to what perfect square which number's perfect square it is. So this becomes 5 5s 25, and we are left with 5. So bring down 2 5 together, add 5 here. So we get here 10, and again if we take the help of 5, we'll get here 5 5s 25, and this becomes 525. So this square root is minus 5 plus minus 55 by 2. So if we take the negative sign, the speed of the train will be negative, which is not possible. So we need to take the positive sign only. So this becomes minus 5 plus 55 by 2, that is 50 by 2, that is equal to 25 kilometer per hour. So the train is traveling at a speed of 25 kilometer per hour continuously. Thank you for watching this episode. Kindly like, share, and subscribe the channel. Hope you like the explanation. In the next video, I'll come with more of these word problems or numericals as we call them, so that you can have a better idea as to how the solutions are done. Thank you.